Yeah. Okay, welcome to another video. So we're going to be dealing with Newton's second law. We're continuing them. I'm giving you guys different questions, so I want you to understand the system, how the system works. You know what I mean? Because they'll change they sometimes change the values and the system there and there they change, but don't ignore the key points. Yeah, that's what I'm saying. Don't ignore the key points. When you read your statements to understand them fully and underline the key points, the key words, the key statements. You know what I mean? And these statements below our diagrams, these ones, most people tend to like not see. You know what I mean? It's not like they're doing it intentionally. It's not like, yeah, it's just that you don't see them. They just read the first one and then look at the diagram and then attempt the questions. But don't forget, look, read everything. Read everything that you see on your paper that is in black. Read everything and understand it. Okay. So now we're on our this is not our last question, guys. I still have more questions. Some of them I'm not done with them. Um yeah, but some of them I think we'll do them together. I don't know, but let's see. Okay, now we're on our question 3. Okay, a 3 kg block P is attached to an 8 kg block R with a light inextensible string that is passing over a frictionless pulley. A force F exerted on block P at an angle of 80 degrees holds block P at rest on a rough horizontal surface. Okay, so now let's go and look at our diagram. Our diagram, which is this one. This is our system, so okay, we have block P, we have block R, so okay, our block P is on our surface, is on our table, this is our table. It's on its horizontal surface, so then they are connected by a light inextensible string that passes over a frictionless pulley, which means there is no friction here. You know what I mean? So there's no friction here. There's nothing here. There's no force here. There are no forces here. Like, it's frictionless. There's no force. There's nothing. Like, the rope is just passing over it. You see, it's just passing over it. There's no friction and stuff like that. So okay, force F. Okay, this block R is dangling. You can see it's hanging. It's not on the surface, guys. It's not on the surface. It's not on a surface. It's just hanging. It's dangling there, up there. Block R. And okay, you can see, okay, let's go back to our statement. A force F exerted on block P at an angle of 30 degrees holds block P at rest on a rough horizontal surface. This is our rough horizontal surface. So okay, this force that is applied, it holds block P at rest. You know what I mean? It holds block P at rest, which means that the system it is static. You know what I mean? It is static. It is static. It's not, there's no kinetic movement there. You know what I mean? It is static. But the philosophy of physics says that these materials are always in motion. They are always in motion. The forces, they don't cause the object like to move or anything. They just change the motion of the object. That's the philosophy. Because they are saying that even when the object is still, like at rest, it is still in motion. You know what I mean? It's just the number is zero. Like it's zero, like zero velocity. You know what I mean? It's just zero velocity. It's not moving as our physical eyes can see. You know what I mean? But it is in motion. So the forces that are exerted on these blocks, they don't cause the object to like is it to exert, yeah, they don't cause our object to like move or anything. They just change the motion. You know what I mean? They just change the motion. So okay, let's go. You've looked at your diagrams. Okay, let's go to our second statement, which is the maximum static frictional force on block P is 50 newtons to the left. So, and you know that frictional forces, they always oppose the motion. So now, here is our maximum static frictional force on block P. It's 15. To where? To the left. So, what does this say about our motion of the system? It means that the system is going where? To the right. You know what I mean? And let's take for instance our F. Force F is not applied here, né? It is just a string connecting block P and block R. And you can see that the masses are different here. There's 8 kg on block R and 3 kg on block P, and block P is less. It's of a less mass. It's of a lesser mass, you know what I mean? And R is of a bigger or larger mass, which is 8 kg block, which means that the block P will accelerate towards the right because it is being pulled by our 8 kg block with a larger mass. And so on. So okay, so now force F is applied at an angle of 30 degrees and it holds block P at rest, which means that our system is at rest. It's not accelerating like that, as we can see with our naked eyes. You know, it's not accelerating as we can see with our naked eyes, but it is still in motion. You know what I mean? So the frictional force is 15 newtons to the left. It is opposing our motion, like we already know by just reading this last statement, that okay, our motion now is to the right. It is to the right. So okay, we've read our statements. Don't forget the key points, guys. Don't forget the key points. Light inextensible string, frictionless pulley, and rest. Okay, light inextensible string, it basically means that okay, when you calculate the tension on block P or the acceleration on block P, the values that you're going to find, like the magnitude that you're going to find on block P for acceleration and tension, it will be the same magnitude that you're going to find on block R, which on our 8 kg block. You know, which means the acceleration is the same overall and the tension is the same overall. The only difference will be the directions. You know what I mean? The only difference will be the direction, because the tension on our block R is it is going upward because it is on our it is just hanging there. It is just hanging there. It's not really on our surface or anything. It is just hanging, which means it will only be two forces that will act on our block R, which is the tensional force, which will go upward, and then it will go upward because this block is dangling, is hanging, is not on a surface, and is not on a horizontal surface as block P. That's why I can't say like the tensional force is going to the left, and then you know what I mean. So it's going upwards, you know, and then the force of gravity is always acting downward. The force of gravity is always acting downward. So on our block R, we only have two forces that are acting there: tensional force going upward and our force of gravity going downward. So okay. Okay, it's okay. Now let's go. Newton's second law. Okay. Newton's second law. It states that when a net force acts on an object, the object will accelerate in the direction of the net force. And acceleration is directly proportional to the net force and inversely proportional to our mass. You know what I mean? That's the definition. So okay, let's go to our free body diagram. They're saying that we are required to draw the free body diagram for block P. Block P. So okay, let's go back to our diagram and look for block P. You can see block P is on our horizontal surface. So which means don't forget those forces: normal force, force applied, force of gravity, frictional force, the tensional force. They are like five forces. You know what I mean? Don't forget those forces. They are like 5. So you'll be allocated marks, like giving you'll be like, the allocation of marks will always it will give you that hint that, okay, man, we only want like 4 forces here because of that 4 marks. We only want 4 forces here. So we're gonna take those first 4 forces that you see acting on a block. Most of the time, sometimes we're given these forces on our statements. Sometimes when I just have to find them yourself. You know what I mean? Just know, we would say, okay, when an object is static, we have a static frictional force. When an object is moving, we have a kinetic frictional force. You know what I mean? Those forces, you need to know them. You need to know them. And a normal force. Normal force is always perpendicular to the surface on which our block is placed. And then the force of gravity is always acting downward. And then our force applied is to our northeast. And this force applied, it is just applied to keep it is just applied, and this force, by being applied, it is holding block P at rest, which means we'll have a static frictional force, as our statement says below. Static frictional force on block P is 15 to the left. So okay, let's go. We already have, let's look at our free body diagram for block P. Okay, I've said the normal force, the tensional force is acting towards our, okay, let me explain about the tension. Okay, the tension here, you can see this rope is connecting block P and R. So it means here there is a tension force. There is a tensional force here, you know. So the tension force acting on our block P will be directed towards our block R. You know what I mean? So then, but the tension force acting on our R will be directed upward, but towards our what? Our block P, but it's upward because it's dangling. It's not on a horizontal surface as block P is dangling. So our tensional force will go upward, and then the force of gravity will go downward. So yeah, the tension force, yeah, don't forget that. And then the force applied, you will draw it as it is on our free body diagram. You can see free body diagram. Don't include the components yet. Don't include the components yet. So okay, the static frictional force, okay, we have him here. The tensional force on block P, we have him. The force of gravity, yes. The normal force, yes. Okay, so now let's go to our questions, our calculations. So now it is required of us to draw to calculate the magnitude of the applied force F. Again, F is our known value, and don't forget that F is on an inclined angle. It is on an inclined. The force is inclined. It's not applied horizontally or vertically. It is just inclined, which means this force is not following the principle of either perpendicular or parallel to the surface. So that's when we are going to look for our components that are going to respect our principle. You know what I mean? Which is Fy and Fx. You know what I mean? Because Fx is parallel to the surface, and then Fy is perpendicular to the surface. You know what I mean? Like, these forces are following our principle. They respect the rule. They respect the principle. They respect the law. Bonsoir. So okay, we have a free body diagram for block P. This one is for calculations. When you include the components, just know it's for calculations. You draw this on your rough sketches. So okay, we have block R. Block R is just dangling, which means only two forces that are going to act on our block R, which is the tensional force going upward and our gravitational force going downward. So okay, when it comes to directions now let's come to directions. Our motion, as I've said before, is to the right because our static frictional force on block P is 15 newtons to the left. So our overall direction is right. So which means our force of gravity will be positive, and then our tensional force will be negative. And don't forget, these tensional forces are opposing one another. The only difference is because block P was on a horizontal surface, and then block R, it is just dangling there. It is just hanging. So, but the forces need to be on opposite directions. This one is going to the right, this one is going to up, it is going up. So you know what I mean? But we're going to take the tension going upward as negative because it is opposing the tension on our block P, which is going to the right, as positive. And then we're going to take the force of gravity on our block R as positive because it is going down. You know what I mean? So okay, let's go to our calculations now. All right. Okay, so now let me explain a thing. There's this thing I want to explain. So okay, you will find a block on an inclined surface and not a force. A block on an inclined surface. So then here it is only the force of gravity that we are going to look at for components, because here it is only force that doesn't follow the principle of either perpendicular or parallel to the surface, because the block is on our inclined surface now. It's on our inclined surface. So then our force of gravity is always acting downwards. So now the components that we are going to look for are of Fg, because the block is on an inclined and not a force. So here you can see that it is only a force that is inclined at an angle. So we're going to look for the components of what? Of the force applied. You get me? All right. And don't forget this thing. Forces acting on our y direction, F0, acceleration. They have zero acceleration, guys. They have zero acceleration. They have zero acceleration. You know what I mean? So okay, let's go now. So okay, we're on our block P. F net is equal to MA, ne? So then let's look at our horizontal forces. We're going to look at our horizontal forces. And when you do these calculations, first look at your horizontal forces, but it will depend on how you grab things and how quick you are in your mind to like spot like simple things. You know what I mean? Like, yeah, it will depend on that. But then, so those that won't know how to do these things, I'm advising you guys to always start with the horizontal forces when dealing with questions. So when you get stuck on the horizontal forces, like, because you'll find that there are multiple variables you don't have values to, so then you will stop there, not like erase the, you will stop there and then go to the other block. You see how I've done things here. Go to the other block, because here I think I was stuck somewhere here. I was stuck somewhere here. So then, and don't forget that the blocks now are at rest. Hey guys, because our force F exerted on block P at an angle of 30 degrees holds block P at rest, guys. At rest. There's no acceleration, guys, but there is motion. There is motion, no acceleration though, but there is motion. I get what given static frictional force to the left, so our overall motion is to the right. You know what I mean? So okay, let's go. As I said, good, see, I was stuck here because I didn't have the value of tension. One. So then let's go to the other block, which is block R, ne? So we have the tensional force, we have the force of gravity. The force of gravity is positive, ne? That's the direction I gave. Is positive. We're going to the right, which means our 8 kg block again is going downward. So it means downward force will be my positive one. You know what I mean? Like the head to tail thing. We need to follow that thing. The head to tail thing. Like you can see, okay, let me say, I get it, on our block P, the tension is going where? One. So then the force that will go downward will be, again, we said is positive here, and so it means the force going downward will also be positive. That's why I took my FG as positive. My FG as positive. We're on block R now. So it's F net is equal to MA FG. So it is FG minus FT. It is FG minus FT. FT, we're saying minus FT because it is opposing the motion. Or one, it is going upward, and our FG is going downward. I took the direction going downward as positive. So it's equals to MA. FG minus FT is equals to MA. So FG, you know that formula. There's this formula of FG is equals to mg, which is a mass multiplied by the force of gravity. Our mass on block R is 8 kg multiplied by 9,8. So then here is 8 multiplied by 9,8 minus ft. We don't have the value of ft. Is equals to 8, our mass. Then acceleration, guys, force that is applied, the force F holds block P at rest. It means now those block P at rest. So it means now the acceleration, I get it, on our block P the acceleration was 0. So it also means that the acceleration on block R will be 0. On block P it is 0 because the block P is at rest due to this force applied on top. So, and don't forget, there is light inaccessible strain, which means same acceleration, same tension on top. So okay, let's go. Let's go. But if I'm not correct, guys, you feel free to correct me. The comment section is there for you to ask questions and to like give me ideas and expand my knowledge, yeah, because I'm here also to be helped by you guys. So okay, let's go. It's 8 multiplied by 9,8 minus ft, which is equals to 8 multiplied by 0, and any number multiplied by 0 is 0. So then our ft, I don't know if, because some of the things I did, I'm tired, so I don't know if the value is correct or what, but you can still do the calculations on your own. Yes, and then ft is equals to 78,4 newtons. So we have our tension now using the block R. Block R. Yeah, okay, we found our tension, and don't forget, same tension on both blocks. So okay, I get it here. Well, I was stuck. So now I have my tension 78,4 minus 15, which is our static frictional force. It is negative because it is opposing the motion, minus F cos dt, fx, which is the component of F, is F cos dt. Don't forget these formulas, guys, these trigonometric ratios. Is equals to 3 is a mass of block P multiplied by acceleration. Acceleration is 0 because our block P is at rest on SWAR. So then now, okay, we have value of ft, static frictional force, and then we don't have this F. This is the person we're looking for. So okay, as we did the calculations, no, this is not fx, it's just f. Yeah, this F. So okay, as you do your calculations, you'll find F as whoa. Hey guys, am I being right here? Let's see, because I think I might have made a mistake somewhere here. Yeah, man, I think I'm done here. There's no need for me to go and write our cos dt is equal to fx, okay? Because okay, let's look at this thing. We have fx, ne? Okay, let's see, fx is our adjacent, and then the trigonometric ratio will be 330, which is equal to fx over f, which is our hypotenuse. It's adjacent over hypotenuse. So then it is f cos 30. We are doing the cross multiplication. Now we're left with fx. So in place of fx, we excuse, I was saying. So this is our trigonometric ratio. Cos 30 is equal to fx over f. This is our f, our hypotenuse, and then fx is our adjacent. So then as we do the cross multiplications, our f is found to be f cos 30. So it means now we have our f now, which is 63.4 newtons. We have our f now. But you guys can correct me, because I feel tired even now. You can correct me. Yeah, this one we don't continue with it. We already found our f. So okay. So now we're still on the same question, just they've added a statement. So force F is now removed. Force F is now removed and block P accelerates to the right. The coefficient of kinetic friction between block P and the horizontal surface is 0.4. Like, guys, go with me, and yeah, I just want us to teach one another. Yeah, let's go with me. Let's help one another. Okay. So force F is now removed and block P accelerates to the right. Okay, the coefficient of kinetic friction between block P and the horizontal surface is 0.4. Okay. All right. And these free body diagrams, these ones, I get it. Say, oh, no. No. I'm still going. Let's go. I get it. It's yeah. I didn't trust it because yeah, but I do trust it now. These free body diagrams, I do trust them. These are they were not required for me to draw. I just drew them so that I can like attempt my questions correctly. So okay, yeah. Block P accelerates to the right, which means now we have, and is given the coefficient of kinetic friction between block P and the horizontal surface is 0.4, which means we have a kinetic frictional force acting on our block P. You know what I mean? The tensional force is already there, normal force is already there, force of gravity is already there. So then on our block R, we still have the same forces, which is our tension and our force of gravity. So okay, let's go. We are required to calculate the acceleration. Okay. The acceleration, which means like the acceleration that I'm going to find on block P is the same acceleration that I'm going to find on block R. But then okay, let's look at our questions. On block P is F net. I get now our force applied is removed, so we don't need to look for the component forces because we no longer have the inclined force. You know what I mean? So here we only have two forces on our block P that are acting horizontally, which is the tensional force and the kinetic frictional force. There's only two forces. So okay, let's go. So F net is equal to MA. This is our formula. This is our formula. This is the formula that we're going to use for the rest of the semester. Let me just note the semester. The rest of the syllabus. Yes. So okay. I get it. It is said that read the statements. Our block P accelerates to the right. So let's take to the right as positive, So it means our tensional force on block P. Well, on block P, tensional force will be positive, and then the other forces that are opposing the motion, they will be negative. All right. They will be negative. So Ft is our positive minus Fk. It is minus because it is now negative. It is opposing the motion. which is equals to 3a. Again, we are now looking for our acceleration. We can't say now acceleration is 0, whatever, because it is now accelerating. It is now accelerating, not at rest. So, okay, block R. Okay, we have only these two forces. All right. So then, and we don't know the value of kinetic frictional force. We don't know the value of kinetic frictional force. You know what I mean? But we can find that guy using this formula. Fk is equals to the coefficient of kinetic frictional force multiplied by the normal force. So here's the thing in here. Yes. Here's the thinking. Hey, here's the thinking. Hey, I got it. I'm getting lost. I got it. I'm getting lost. Yes. Look at our look at our field rate body diagram at block P. Ne? We don't have the components here. It is only forces that are acting, like the direct forces that are acting here. So, and don't forget that block P was on our what? On our horizontal surface. So this thing is pulled horizontally, not vertically. So it means vertically, our acceleration is what? Is 0. All right, let's go. It means our acceleration vertically is 0. So and then if it's 0, okay, let's look at our okay, our vertical forces on block P. Excuse guys. We have the normal force which is acting upward. I'll take that as, okay, let's use the formula F net is equals to MA in order to work out our vertical forces. So we have the upward force, which is a normal force. I'll take that force as positive, and then the force going downward, I'll take it as negative. But then don't forget that I said previously the FG, it was going downward. You know what I mean? I said the FG was going downward. So let's just because now let's just say FG is equal to normal force. This is the same. You can take normal force as positive and then FG as negative. It will be negative FG, which is equal to, just know that the acceleration is 0 because we're now working with forces on our horizontal, and the object is not being pulled upward, it's being pulled horizontally to the right or to the left, not upward or downward. So our acceleration on our downward or upward motion is 0. Hence here we'll have a 0 number. So newtons is equals to and the normal force is equal to Fg automatically. You know what I mean? It's equal to Fg automatically. So here I get it, we don't have the kinetic frictional force, but we can find the kinetic frictional force, right, using this formula. So we do have our coefficient of kinetic frictional force, but we don't know our normal force and we don't know our kinetic frictional force. We just only have the coefficient, but we can find the normal force. Again, I've said the normal force is equal to the gravitational force because our acceleration is 0 on our y direction, on our vertical direction. Yes. So okay, the coefficient of kinetic frictional force is 0.4. We have him. So again, our normal force is equal to Fg, and we know the formula for Fg. The formula for Fg is equals to mg, which is equals to, what is our mass on block P? It's 3, right? What is our force of gravity? It's 9.8. Okay, still. So okay. Yes, so punch this in your calculator. 0.4 times 3 times 9.8. I found 11.76 newtons. This is our frictional force now. Or frictional force. Okay, this is our frictional force. So okay, yeah, I get it. We're busy working with our horizontal forces. It means the acceleration is still unknown, and we're looking for the acceleration, for the value of acceleration, for the magnitude of acceleration, right? So okay, ft minus, I get it. Here's our fk. So we found our fk 11,76. So it will be ft minus 11,76, which is equal to 3a. 3a. So then just make ft the subject of the formula, and then we're left with okay, is ft is equal to 3a plus 11,76, because this one changes the sign as it jumps over the equal sign. So okay, let's go to our block R. Here you can see we don't have ft and we don't have acceleration, so this will be our first equation, right? So then let's go to block R. Block R is f net. F net is equal to ma, right? Excuse. F net is equal to ma. So it will be okay. We're working with the horizontal forces. Don't forget that. So Fg is equal to Fg minus Ft is equal to 8a. Fg is positive, then Ft is negative. Don't forget that our overall direction is to the right. So whichever the force that is opposing the motion is negative. Is to the right. Don't forget that thing. The head to tail thing. I get our block P is accelerating to the right, and our 8 kg block now is going downward. So the force Fg, I'll take it as positive. Don't forget that. So Fg is minus Ft is equal to 8a, and then Fg value, we know the formula m multiplied by g, the force of gravity. So it's 8 multiplied by 9,8 minus Ft, which is equal to 8a. So here, okay, help me with the calculations, guys, because I don't have a calculator. Yeah, my calculations here we messed up. Yes, we messed up. But then okay, let's go. You can see that is m multiplied by g. Let me look. Okay, let me look for a calculator. All right. It's 8 times 9,8. Okay. It's 8 times 9,8 is 78,4. 78,4 minus 8a, which is equal to ft. This is our equation 2, right? So okay, yeah, you can substitute, you can equate these equations. You can equate equation 1 with equation 2, right? Yeah, you know what I mean. You can equate these equations. Yes, you can equate the equations, and then yeah, you can see, yeah, you take 3a plus 11,76 and then equate to 78,4 minus 8a, and then here you calculate and then find your acceleration, which was 6,06 meters per second square. If I'm wrong, guys, leave the comments, leave your comments in the comment section below, so that I can know where I went wrong. Hey, I'm tired and I'm hungry. So tired and I'm hungry, guys. Okay, so guys, I'll come up with other questions later tonight. Yeah, later tonight I'll be doing other questions. So then for now, yeah, asiyekeni la, yabona, ayisigimeteni kwala mashaka.